Kids, welcome back to the shop. Today we're going to build a miter gauge for the table saw. On the last video on this particular project, I told you guys to leave a comment, and it was overwhelming. Build a miter gauge. So that's what we're going to do today. So I took some measurements here. The slot was actually 0.633. I decided I could live with a measurement of 0.630. My aluminum that I purchased off of my favorite place, Amazon, was 0.987. So that's a difference of 0.357. I already blued it up with my favorite stuff, my liquid fluid, layout fluid, I mean. And what I did too is I 3D printed this thing. Now it did take a while. I forget, this might have been like 6 hours or something, but I printed it on draft, so it's not obviously it's not the best quality, but I think it's going to work out pretty good. It'll go on like, and I forget what these are like. I'll let you know, but there's a hole here. I'm going to put the bolt in it, drill a hole, mark it, blah, 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 all that happy stuff. So let's head off to the mill and let's mill off 0.357. All right, this is where it gets a little hokey. I did mark it at 0.357. You see the mark right there. And then I have my machinist jacks set up because the aluminum's sticking over. These things are hokey. They never really worked right, and I never got around to building ones that would work. So you're going to see what's going to happen here. The jack is supposed to support the piece so I don't get any vibration. But the problem is I can't get the jack tight enough. When I tighten it up, it sort of moves the piece in the vise. That's not supposed to work. Or the jack is vibrating because it's not secured properly to the table. This just isn't working. The piece isn't parallel to the table, so I'm not getting an even cut. I don't want to go to the line and take too much off. I'm going to get as close to the line as possible, and then I'm going to fine tune it with a file. Something I didn't show you is I took a majority of the material off with the bandsaw. I knew I was going to have a hassle with vibration. I was hoping I was going to be able to just make this in one cut or two cuts, but obviously things went haywire. I clean up the rough edges with a file. Now let's do a test fit. And you see it's still binding up here at the top. So I'm going to file that a little bit more. Here's the other thing that's screwy, is now on this side it goes all the way through. So I got to watch how much I take off because I don't want to have too much slop. I'm going to put some bluing fluid on this thing and run it through, see where it scrapes. Then I have a better idea of how much to take off. Alright, you see I have that blued up. See if this works. Scratching right there. You see that right there? So I'm going to hit that with a file real quick. Just that little area. Well, I did that several times, and then I started to use sandpaper, and look at that. So now what we're going to do is we're going to mark where this pin will go. Remember, I'm going to thread that bolt into here, drill a hole, and just going to pin it. Head over to the milling machine. I use the DRO to find center. I spot drill it, then I drill a clearance hole for the bolt. Now remember, this bolt is just acting as a pin. This portion is not threaded. The threaded portion is the actual miter gauge. Alright, this thing's finally starting to look like a miter gauge. I threaded that bolt into the miter gauge. I cut the head off. I fit the gauge to the slide, trimmed it so it didn't interfere with the bottom of the slot. Alright, this is working pretty good. I center punched a hole right here. It is approximately the center of this slot. And this is an M6 bolt, M6-1. So now what I'm going to do is go to the mill, find the center just like I did there, drill and tap this, and then cut the head off, and this will be a stud sticking up, and for a knob it'll stick up, the head will be off, and then I have to go to the lathe and make a knob for it. So I have my handy dandy tap drill size chart, and remember I told you it was an M6x1, which is right here. So that drill bit size is a number 10. So let's grab a number 10 and we will tap and drill. Just like before, I use the DRO to find center. I spot drill it. I drill it with a number 10 drill bit, and then I tap the hole to size. I got the stud threaded in place. It's fitting pretty good. Now I'm going to Loctite it in place and head over to the lathe and make a knob. Well, you guessed it. I forgot to turn the camera on. So that area right there, I'm going to make that 3/4 of an inch, and then the knob itself, where you're going to be grippy, that's going to be close to an inch. So let's continue turning this down. .741. We're supposed to be at .750, so I took too much off, but we can live with it. Alright, let's drill and tap this thing to size. We're in a home stretch here. Alright, let's make the knob part. First I just clean it up, and then I knurl the end. After cutting it to length, I face the end off, put a couple chamfers on it, and this thing's looking pretty good. This thing turned out pretty good. I like it. Now let's get this miter gauge assembled. I got this thing assembled. We're going to square it up here. But I do want to show you that, see, I put a punch mark right there. That's on 0. I actually took that square and I squared everything up. Made sure 0 was where 0 should be, if that makes sense. And then I smacked it with the punch. Alright, let's make a cut. See how we did. Well, first off, the blade's turning in the correct direction. It's cutting well. Now, quick check with the square, and this thing's looking pretty good. Success. Well, I cleaned this thing up with some steel wool. It's looking pretty good. Everything's working as it should. It's square. The knob turned out nice. Leave a comment. Let me know what you think. The next thing I have to do is make a guard for this. Thanks for watching. Please subscribe.